Hi everyone. What answers did you get for the first one? Okay, good. 21 is correct. Let's see, Nidhi or Neil, can you explain?
Okay, so all I did was take the LCM of 12, 14, and 15, which is the price of the red candy, green candy, and blue candy. And the LCM of those numbers was 420. And then I just divided 420 by 20, the cost of the purple candy, to find the smallest possible value of n as 21.
Good. Yeah, so that's exactly right here. The reason is that we know that if Casper has enough money to buy each of these, we know that it must be 12 times the price of a red candy, 14 times the price of a green candy, 15 times the price of a blue candy. Each is a whole number of cents. So we know the number that Casper has is a multiple of all of these, 12, 14, and 15. So that means that if you take the LCM, that's kind of like the smallest amount he can have. So if a piece of purple candy costs 20, he can have the LCM divided by 20. So 21 is the smallest value of the number of purple candies he can buy. Another way you could also look at this is just saying, so you know that 12, so this is basically like 12 times the price of a red is equal to 14 times the price of a green is equal to 15 times the price of a blue, which is also equal to 20 times something. So this extra term, we know that if there's any prime factor in these numbers that is not covered in 20, it needs to be in this number. So we can see that 7 is a factor. In 14, 2 is already in the 20, so 7 is not there. 7 needs to be a factor of g. In 15, it's 5 times 3. So both of those need to be part of g. In 12, 2 to the power 2 or 4 is already part of 20, so 3 is the only prime factor that's not covered. So 3, 7, and 5 are, sorry, 3 and 7 are the two prime factors. The 5 is covered in the 20, so G is 21 in that way as well. Any questions on this? Okay, let's go to the second one. Okay, 5 is correct. Ishan, can you explain?
Yeah, so I for when it says like 95 green marbles, I just assumed there would be a 45 in like the jar 1, which is the ratio of 9 to 1, and then 50 in jar 2, which is the ratio of 8 to 1. So then you just have to multiply jar 1. So you just have to do 45 times 9, which is 405, and then you get 405 blue marbles and then 45 green marbles. And then for the second one, you just do 50 times 8, which is 400 blue marbles, and then 50 green marbles. So then you just do 405 minus 400. Then you just get 5.
Good. Yeah, so we know that the ratios are 9 to 1, 8 to 1, and we know there's 95 green marbles in all, right? So if you think about the total, so we know the total of the two are the same, total number of marbles. So this, when you think about the ratio, it's a total of 10. This ratio is a total of 9. So if we have a multiplier for this, the multiplier of the first has to be 9 times the multiplier, or has to be a ratio of 9:10 with this 8:1 ratio. Now, there's a total of 95 green marbles. If you want to split it in 9 to 10, if you divide by 19, it's 5. So we want to multiply the first one by 45, the second one by 50. So that actually gives us, so 45 times 9 is 405 blue marbles in the jar 1 and 45 green marbles in jar 1. In the second one, it's 400 blue marbles and 50 green marbles. So we know that 405 blue marbles in jar 1 and 400 blue marbles in jar 2. There's 5 more in jar 1 than jar 2. Any questions on this? Okay, let's move to the last one. Good. 6/5 is correct. Nidhi, can you explain?
Yeah, so to be honest, it was a lot of ratios that I did, and I'm not the best at explaining those, but I'll try my best.
Okay, go ahead.
What we know is it's a 1-to-3 ratio from like the home to the gym, and a 3-to-1 ratio as vice versa. So I found the equation 3/1 plus 3 plus 1 times 2 is, and then solve that by doing a 1-to-3-to-1 ratio. That's not the greatest explanation, but do you have any questions on how I did that? I'm not really the best at explaining ratios.
Yeah, I think you're on the right track. Let's maybe just look at it pictorially. I think there might be an easier way to just see that same argument. So I think one approach also to kind of start with this problem is you can think about like when you start at this point, okay, you go 3/4 of the way to the gym. You can imagine coming back, and you'll imagine that like kind of you'll converge to like going between two specific points gradually. But when you think about that state, it's like you start from one point here. You'll go 3/4 of the way and you'll come to a point here. Then you'll go 3/4 of the way back home and you'll end up back at the original point. And you'll be going back and forth at these 2 points, right? So we know these points are A and B. Let's mark them here. And this is we know the total length is 2 kilometers. Now we know from A to the one endpoint is the home, and the other endpoint is the gym. So we know from A to the gym, whatever the distance is, A to B must be 3/4 of that. So basically, if A to B is length 3, B to the gym is 1. So this is a 3-to-1 ratio. Now we can think about it the other way. So starting from B to the home, this is B to A is also 3/4 of the distance from B to home, right? So this is also a 3-to-1 ratio. So let's just assume that A to B is length 3. So this means that B to the gym is 1 and home to A is 1, right? So the whole thing we know is basically if this is 1, this is 3, and this is 1. So we know that we want to split the entire distance in a 1:3:1 ratio. And that would give us a point where if it go from here to home, I would be going 3/4 of the way. If I go from here to the gym, I'd be going 3/4 of the way to get to B. Now, if the total distance is 5, I can divide, if the total distance is 2 kilometers, I can divide that by 5, 3 plus 1 plus 1. So that gives me 2/5. And then we can multiply by 3 for the center portion. So it gives us 6/5, or 1 1/5. And that's the distance from A to B here. Any questions on this? Okay, so there's one more way you can actually apply this, which is probably a little bit trickier compared to this, but you could also think about it algebraically. So you can think about position B, position A, and the 0 and 2 markers, and you can think about, okay, so I know that B minus A is going to be 3/4 of 2 minus A. And I can think about that A is 1/4 of B, or I can think about it like A minus 0 is 1/4 of B minus 0. And you basically get 2 equations that you can solve here. You will still get the same values, but this is another way you can think about it as well. If you want to do it purely algebraically, but the kind of geometric way is easier to think about in the ratios here. Any questions? Okay, that's it for today's class then.
Thank you.
Thank you. Bye.
Bye.